So first things first, I'm asked to write these in a rectangular form and then give the domain range. So I'm going to look at my two equations and really kind of write one of them in terms of t. Seems most obvious to me to rewrite this one. So if I do that and I divide both sides by 2, I get t is equal to y over 2. So x is equal to negative 1/2, and then I'll substitute in my y over 2 squared minus 1. And so when I square both sides, when I square y over 2, it becomes y over 4. When I multiply by the negative 1/2, I get negative y squared over 8. And then I'm going to try to get the y by itself, because again, if I'm writing this in rectangular form, usually we start with y equals. So I'll start by adding 1 to both sides, and then multiplying both sides by negative 8. And then I will square root both sides. So when I square root both sides, again, that creates the plus or minus. And I can simplify that 8, or the square root of 8 a little bit, right? That's 2 root 2. So I'll move a 2 out front. I'll leave that like that. Or I guess if I looked at the answers again, I would have seen that really we just left it in this form. So that's fine. You don't have to do this, although it's not incorrect if you did that. Okay, the next thing we want to do is look at the domain. So looking at the domain, I'm going to be looking at the x's, and then using this interval for t. So if I look at the kind of function that x is a quadratic function. I can tell because the t is squared. And I can tell that this quadratic function is opening down. So it's going to kind of look like this. And since the t is going for all real numbers, I know that my domain here for the x's is going to start at negative infinity and then end up here at, so negative infinity because the arrow is pointing down, and we're going to end up here at the y coordinate for the vertex. So remember, for a quadratic function, we can find the vertex by doing negative b over 2a, comma, and then plugging that negative b over 2a back into the function. So if I go back and I look here, this is in terms of x and t, where t is the independent variable. So like, this is my x and these are t's. So here I can see that negative b over 2a is just going to be 0, right? Since there's no term with just a t in it. So when I plug that back in, I get 0 squared, which is 0, times negative 1/2, which is still 0, minus 1, which is negative 1. So that negative 1 there is going to be the tippy top of my domain. Now for the range, we're going to be looking at the y coordinate. Since the y is just a linear function in terms of t, and the values for t are going from negative infinity to positive infinity, well, I can get any y value I want by plugging any number in, so the range is just also going to be all real numbers. Let's look at 23 now. So again, I'm going to start by trying to get one of the variables in terms of t. I'm going to stay away from that quadratic one, and I'm going to start with the y again. So to get the t by itself, I'm going to subtract 4 and divide by 3. And when I plug t in, I have negative 2 times the quantity y minus 4 over 3 squared. So again, we want to get the y by itself. So I'm going to start by dividing both sides by -2. And then I'm going to square root both sides. And then I'll multiply both sides by 3. And then we'll add 4 to both sides. And I would be okay with this as your final answer, but it doesn't match what's in the answer key. So just to show you how we get that same thing from the answer key, what I'm going to do is I'm going to fix this radical so there's not a square root in the denominator. So to do that, I'm going to multiply the top and bottom of this by the square root of -2 over the square root of -2. And then we notice that the square root of 4 is just 2, so that 2 is going to come out in the denominator. And there's the answer that matches our answer key. So let's then worry about the domains and ranges. So the domain, we're going to be looking at our x. So again, here we're going to worry about where the y coordinate, or the vertex of this quadratic. And we know the vertex of that quadratic happens when t is 0, just like before. And then notice here that the interval for our t's is not all real numbers. So I'm also going to be concerned about when t is at each of these endpoints. So when I plug 0 in for t, I get 0. When I plug -4 in for t, I get 16 times -2, so it's -32. When I plug 3 in for t, I get 9, -18. So I want the biggest and smallest from that list, so those two. So here x is on the interval from -32 to 0. Is our domain. To do the range then, we're going to be worried about the y. Now since the y is a linear function, and linear functions are everywhere increasing and everywhere decreasing, I really only care about the endpoints of my interval, because I know the lowest point and highest point on that line segment is either going to be at the very beginning or very end of the line segment. So when I plug 4 in for t, I get 16. When I plug 3 in for t, oops, I don't get 16. That was a -4 I was plugging in. Sorry, so that should be -8. And then when I plug 3 in, I get 3 times 3, that's 9, plus 4 is 13. So my range then is from -8 to +13.